KYAI pod. We're here with Jivan. He is back next to Clay. Jivan, how about a wave for the audience? Full turn wave. All right. You're going to wave away from the audience, Jivan. All right.
We'll give him one more. Just for the people.
There we go. There's a full frontal wave. Today, there is a lot of noise in the marketplace. The new OpenAI image gen capability that they released in the 4.0 model. Clay and I were just playing with it. I was working on humanoid robots, trying to figure out if we can get Jivan a friend or maybe an image. So I just created this one. Everybody's talking about how the servers are burning up. One of the things that is so interesting about the time required to generate these images is it does get you nostalgic for the early internet download time frames of simple images. It takes a while to get started. As you know, the early internet emerged, you get the slow roll of the content over time. We'll see how fast this one comes. We get a blurry one. I'm going to see if I can get a humanoid robot racking a server here. This is my goal.
There we go. Turning up the complexity a little.
Yeah. All right, see, here's that slow roll content, circa late 1990s. The slow unveil, lots of anticipation. The eyes on this particular humanoid are a little vapid.
Yeah, it looks like it's taken the robot command very literally, but I'm not sure it knows exactly what the Unitree looks like.
No, it probably doesn't have a ton of images of the Unitree G1. It is racking some servers though. That's awesome.
Yeah. I mean, that's what we touched on a little bit last week with, we were discussing the inability for most of these image and video generators to actually encompass a lot of what the prompt was describing. And it seems like OpenAI answered the call a little bit with, this is one shot and it looks pretty solid as far as the prompt you gave it.
And what's the internet is fired up over the Studio Ghibli style guide, right? Clay, is that
exactly
accurate view?
Yeah,
Okay.
Kind of that old animated vintage, the ones my generation grew up on a little bit. They're classic.
Okay. Very cool.
Jivan, what do you think of your friend there? Yeah, no voice capability yet, but that's coming soon.
Yeah, we'll get voice rolling shortly. Cool. Well, what we want to talk about today a little bit, as we talk about the latest in AI. One of the things that we're really excited about is one of the premier manufacturing events globally, certainly in the Western Hemisphere, is Hannover Messe. We're going to be releasing a new AI agent for manufacturing operations. As we all know, manufacturing is a difficult industry where yields are incredibly important and equipment downtime can cost massive amount of money, from tens of millions of dollars or hundreds in semiconductor manufacturing, to yields on really important cost thresholds. And one of the challenges, there's a lot of tribal knowledge with manufacturing. And you get different operators coming in and they're trying to tune up machines to make sure they run well, they get high yields and high quality. But when issues occur, sometimes the experts aren't there to see them, and experts can't work 24/7. And we built an AI agent that monitors manufacturing infrastructure. One of the really cool things about this agent is it manages both SCADA infrastructure, so legacy manufacturing infrastructure. As you guys may know, SCADA powers everything from nuclear power plants to dams. Is a typical SCADA architecture. But there's modern techniques to pull digital data off of manufacturing lines, like connectivity protocols such as OPC UA as well. And so while you might have a brownfield manufacturing environment and a new manufacturing environment together, there's a huge opportunity to kind of merge those data sets so you don't have siloed data sets, and be able to apply these new techniques like having an AI agent analyze your equipment when failures occur, conduct a thorough root cause analysis, update the next shift on that root cause analysis, do all the paperwork for you in creating that root cause analysis report. So I want to showcase what we were showing off at Supercompute.
I'm going to let our good friend Jivan get out of here.
So we did this work in collaboration with Dell and AMD. One of the coolest things about this solution is we're actually running on the 5th gen EPYC processor without a GPU. So you heard that correctly. We're running a full AI agent monitoring manufacturing infrastructure without a GPU. And as I discussed earlier, we're running on Scala architecture, OPC UA. Huge challenges in existing manufacturing environment. You got to correlate all these disparate systems, ultimately relating to extended downtime, quality issues. So we unify that legacy data and the new digital data into an AI agent, stream it all the anomalies. It conducts root cause analysis, and it uses that prior knowledge graph that's sometimes tribal knowledge or expert knowledge, and applies that in the root cause analysis and report generation as well. And ultimately, this AI agent can connect to your Jira system and your ticketing system as well. What we see here is we're illustrating that AI agent. We've got 3 types of sensors: torque, vibration, and pressure, which are integrated into SCADA. And then we have our MEMS-based OPC sensor that's integrated with OPC UA for quality control. Really common problem would be that disparate legacy SCADA environment, and then we've got this new environment as well. And we're ingesting all these events, both in the SCADA events, triggering alerts basically when thresholds are exceeded. So we have all the parameters for your ideal pressure, vibration, and torque highlighted here. And when we go out of calibration, there's an event alert that occurs. And simultaneously, we're correlating that to the output quality issues so we can understand if that calibration issue is driving a quality issue. And then you can click on it and get a root cause analysis. This is all AI generated, all on CPU, which is really nice. So any of these alerts, you can just select the alerts, and then AI will generate a root cause analysis based on its prior knowledge graph of the issues, the calibration settings it sees. In this case, it's talking about verifying the alignment because we've got some rotating part issue here. And you can guys see the subsequent next steps, recalibrating the sensor as well. And we also added the chat capability. So a user can come in and say, hey, I don't want to click on every event. I just want to look at the last 7 or so events. So we've got the time pressure sensor showing up here as an issue that's happened in the last 7 minutes. We can see how the AI model is reasoning through this as well. We added reasoning capability to this particular system. That's right, we got reasoning running on a CPU as well. So really, really nicely done there. And one of the most important things, I think, is you run 24/7 manufacturing facilities. You need to hand off to the next shift, tell them that what's happened on the current shift, what you're doing to address those issues. And you have to provide root cause analysis reports and thorough reports if you're seeing major issues on the machines. And we can also ask the assistant here to provide a report on recommended resolutions for the issue, and a full report out of the issue as well. So here we're just manually coming in, looking at the issues that we've got, and we've got a root cause analysis conducted, and then we can create this downloadable report. And you can see this is all AI generated, this inspection report over time, talk about all the timestamps, time series, takes that SCADA-based information, the new quality MEMS-based information as well, merges those 2 data sets, gives us really refined detail as well. If you look at our solution workflow, we're showcasing that legacy SCADA infrastructure, the new industrial machine sensors that we've added. We're taking that in, streaming that into our time series database, and ultimately into our AI agent framework. This is how we built the solution. Really cool that we're able to fit an 8 billion parameter model all in CPU, of course, with the vector DB, with serving as well. So a lot of capabilities packed into just a 5th gen EPYC processor. And big shout out to the team over at Dell and AMD for making this possible. And you can see this at Hannover Messe next week. It's pretty exciting stuff.
Yeah, that's super exciting. Do we want to just double click on kind of like that CPU versus GPU capability we're showcasing there? I know that's an important, maybe if not the most important feature. AMD is fired up about it. Just kind of talk a little bit about what that means and how that's implemented.
Yeah, I think what we're seeing in the market today is AI agents present an incredible opportunity to make a decision between how real time your AI needs. And with the advent of chatbots, and even if you see this image generation for consumer applications, when you've got a human in the loop real time, there's a lot of pressure to have really, really fast throughput and tokens per second performance per user. But when you're running a 24/7 manufacturing facility, hopefully it's running well. There's not a huge amount of alerts or events occurring. You can batch some of those workloads into a CPU. So you might do a report out, every 4 hours, or a shift-based report on an 8-hour basis. It's not as real time in that particular environment, so it's not required. And your operating personnel are not always chatting real time with the AI agent as well. AI agents also, since we give them access to tools like API calls, they can fill out their own Jira tickets. And then that can drive a truck roll or a software update or a maintenance replayer as well. So there's an incredible opportunity to eliminate the speed requirements of human in the loop. Still, for a real-time application, you're going to want a GPU. But if you do have a batch-based application, you can really run a full AI agent on a CPU. And obviously, CPU infrastructure is prevalent in the market. You can use it for other things too. That's what's great about it. CPUs, general processing, is a Swiss Army knife, so you don't need to just run your AI agent on it. You can use it for other things at other times. And so that's going to give you total cost of ownership value for those mixed type of workloads as well. So that's why it's so special that we can run on CPU. And I think the advent of AI agents and enabling batch-based processes and integration with tools and human out of the loop is really what allows us not to have that real GPU-intensive requirements in all scenarios.
Absolutely, and I feel like that's something you just don't hear about a whole lot in the AI space. It's GPU, NVIDIA, all these different things. So it sounds like CPU has re-entered the chat and has carved out its own little use case there. So
yeah, absolutely. I don't know if that's the right characterization, because it's not re-entering the chat, but it's definitely for AI batch-based workloads. CPU is a secret weapon for batch-based workloads. For the chat and real-time consumer applications where people don't have the patience, that's where I think a GPU is.
No, I didn't mean like the literal chat. I meant like it's back in the conversation, people's minds.
Yeah, I know you didn't mean it literally.
Okay, cool.
Yeah, as well. But as everybody's sitting around frustrated based on the internet era speeds of image generation on the new OpenAI launch this week, I think it's a great example that consumers have extremely high expectations. But for someone that has to manually write a shift changeover report and go through all of the calibration issues they're seeing, conduct a manual root cause analysis that they have to type up before they transition to the next team, generate tickets for the next team that drives truck rolls, etc. This is a huge time saver, and so even if a report takes a couple minutes to generate and it's not real time, there's incredible value. And they can take advantage of it today because in most manufacturing environments they have CPU-based infrastructure today, and they can support CPU-based on-prem infrastructure where GPU infrastructure takes a little bit of onboarding for that D team on site as well. So exciting stuff. You will see it live in Hannover Messe as well. Thanks, Clay, for tuning in today.
Sounds good. See you at Hannover Messe.